Today we're going to learn how to add directions, how to add vectors, and that you're going to learn a rule that I'm going to repeat a gazillion times, almost as much as get the obvious one, or almost as much as who's winning. But because I know some of you just like to write things down, you can, if you wish, write the rule on your purple sheet. Can't redo it on your yellow sheet, though. So, recall in physics, all measured quantities are either scalars or vectors. It wasn't hugely important in Physics 11. It will be much more important in Physics 12. Scalars have magnitude only. Scalars have size. It's possible that you can fill in the two blanks here. Vectors have both. And usually I say magnitude and direction, but they have direction and magnitude, or magnitude and direction. Vectors have magnitude and direction. Scalars have magnitude but no direction, much like your futures. Sorry, that came out wrong. Patrick the puppy goes for a little wander. Patrick the puppy starts right here on the front porch, and it looks like he walks 5 meters in this way. You know what? Instead of in this way, why don't we be clever? I'm going to throw a little compass rose on the side, and you're going to find this is one of the first things we'll do anytime we see an angle in a question, anytime we see a compass direction in a question, like the north or a south or an east or a west, we'll draw the compass rose out. We feel better, Petco, but it cuts down on dumb mistakes. So it looks like Patrick the puppy walks 5 meters north, then 4 meters east, another 4 meters east, 2 meters south, and then 4 meters west. And I've drawn each little mini trip with a series of arrows to scale. Each arrow shows the magnitude, the size, and the direction of each successive trip made by Patrick the puppy. These arrows are called vectors. When Patrick reaches his final spot near the car door, how far has he walked since he left the front porch? And that depends on what you mean by how far. If we want to know his distance, that would be the number of steps Patrick the puppy took, which would be 3 plus 2 plus 4 plus 4 plus 2 plus 4, the length of each little mini trip, which is what? I can do this in my head. 3 plus 2 is 5 plus 4 is 9 plus 4 is 13 plus 2 is 15. Is it 19? Double check me. Yes? Units, 19 what? So one way to answer the question how far would be to say how many steps? 19 meters. Or we could do his displacement. Now his displacement is his change in position, which is that little line, that vector, right there. How the heck could I figure that out? Well, in the white space right here, I'm going to redraw that line. But then I'm going to add a dotted line there and a dotted line there. What shape have I just drawn, Manchand? Be obvious, it starts with letter T. Yes. Is there a right angle right there? We can use Pythagoras and SOHCAHTOA, which is why I did the trig review. Did I do the trig review? Yeah, I did the trig review with you last day. How long is this baseline? Look at the picture and see if you can figure it out. Sorry? I agree. How long is this vertical line, the north line? 3. Do the Pythagoras. How long is the hypotenuse? Is it 5? It's a 3, 4, 5 triangle. If you go 3 squared plus 4 squared, it equals 5 squared. This ends up being 5. So first of all, for the displacement, the magnitude is going to be 5 meters. But then I draw a little at symbol because I need to give a direction. What's the direction? it's going to be this angle theta here. How big is that angle? Color, 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 color. That 3, opposite, adjacent, or hypotenuse, Manchand. That 4, opposite, or, sorry, good. I could use the 5, but since I calculated the 5, just in case I got it wrong, I'll use the 2 values that I got from the diagram, because I'm a good test writer. It's a habit that I've developed. Which trig function has the O and the A in it? Okay. By the way, it might be smart at the top of your page to write just me thinking, but that might be a handy-dandy little thing to have. Which trig function? What always goes next to the trig function? The angle, in this case, angle theta, which will be the variable that I almost always use for an angle, a Greek letter, a 0 wearing a belt. 3 over 4. On your calculators, how big is theta? Kai, what'd you get? 0.01. Nope, that can't be the angle. 0.01 degrees, you couldn't even see that with your eyes. So you either forgot to hit the second function or the shift button, or you're in the wrong mode. And this is not to make fun of you, but I am going to say, look at that angle. That's almost 45 degrees if I've drawn it roughly to scale. 0.1 degrees would be a bad guess, yes? So let's start analyzing our calculator values and catching that. Owen, help me out. 36.8, anybody else? 36.9, round it off properly, yes? Is that right? Let's call it 37, because I usually go to the nearest degree or at most 0.1, because 1 degree, Owen, is only about like that big. 0.1 of a degree, the naked eye can barely spot. So how accurate do we want to be? Sure, what do you say, 36.9? I'll fine, do that. Or 37. But now I need to somehow show that it's pointing that way. We would call this north of east, and we'll practice that later on in today's lesson. We would say that his displacement is 5 meters at 36.9 degrees north of east. Also why we'll always draw compass roses on these things, just so we can do that easier without having to scratch our brain too much. There are 2 ways, Matt, to indicate that something is a vector. In a textbook, you'll often see a vector in bold font. So, for example, force is a vector. In a textbook, you'll see the letter F in a bold font. But the problem is when you're handwriting, that's really, how do you show bold font? And so rather than bold font when we're handwriting, we use a little vector arrow. That's the vector, the force vector. Although we've gotten lazy over the years, and instead of a full arrow, we only do a little half arrowhead. We're that lazy over the years, okay? So F symbolizes a force vector in bold font, but that's really tough to do. So if only the magnitude is wanted, by the way, a textbook will often use plain italics, or in handwriting, we'll use the absolute value symbol. Now, you learned in math last year, you saw that absolute value. What's the absolute value of 5? What's the absolute value of -5? What you were really saying is, what's the magnitude of that negative number? It's 5 big. So we use it in physics too. So, scalars and vectors, if you add 3 kilograms of sugar to 2 kilograms of sugar, you get 5 kilograms of sugar. Well, duh. If you add 3 liters of water to 2 liters of water, you get 5 liters of water. Masses and volumes. Good morning, are you here?
Yeah.
Okay. So mass and volume are scalar quantities. They have magnitude only. It makes no sense to say 5 kilograms south. Doesn't make any sense. Other scalar quantities. Who remembers some scalars from last year? There was one that you might remember is a scalar. So speed was a scalar. Okay. Distance was a scalar, as opposed to the other one. Other scalars that we would have got to last year, mass, I already mentioned. Energy, which we'll get to this year, is a scalar, which is one of the reasons we'll use energy to analyze roller coasters, because roller coasters from the side view are changing direction all the time. You can do it with a vector approach, but you absolutely need calculus then. You can't do it without calculus. So we'll use a scalar approach. There's a concept in physics called work. It's a scalar. Oh, the big one, time. So one thing that I was going to mention yesterday, when you're solving a quadratic equation for time, you just chuck the negative answer, because you may have noticed with a quadratic, you get two answers. Which one do I want? If we're using a real life situation and solving for time, you'll always get one positive and one negative answer. You chuck the negative answer because time is a scalar, it's positive. If you add a 3-meter displacement to a 2-meter displacement, the two displacements together, they may add up to 5, like this. But they could add up to 1, 3 forward, 2 back, or they can add up to anything in between. This adds up to 3.6. This last diagram, we added those displacements by the rule for vector addition, which I'm going to give you in a few minutes. But can you see the length of what's called the resultant depends on not just the magnitudes of the vectors, but the direction they're pointing. 5, 1, I can give you any length in between 5 and 1. Tell me what length you want, and I'll show you how to draw the two vectors and add them to get that answer. In addition to displacements, other vector qualities, so there was force, velocity, acceleration, although often we just found the magnitude, especially if there was more than one mass, because they were moving in different directions. So often we just found the direction, the magnitude, but it certainly mattered which way the acceleration was if we were trying to solve something. If you're in free fall, you had to make sure you're accelerating down, not up. One that we did after spring break, if you followed along in our remote learning, momentum is a vector. Question? I can't hear you, sorry. Third one, excel. Come on, you know I tend to abbreviate. Here, I'll make it easier for you. That's really what I should have written. Now, if I did that, as soon as I go with the symbol, it just irks me. I should put the vector symbol on it because it is a vector. That's like fingernails on the blackboard to me. I will not take marks off if you don't put a vector symbol on something, but you'll lose the marks naturally if you're casual, because you might suddenly start doing scalar math for a vector answer and you're going to get the wrong answer. So just be a little nitpicky, meticulous. So if we add together 7 newtons and 4 newtons, what's the maximum force we could get? In your heads. Jack. Oh, I thought you were right. No, I thought I saw it. Sorry? Loud and proud. You're right. Say it again. Yep. That would be both pushing in the same direction. What's the minimum force I can get? 3, pushing in opposite directions. What if we push at angles? Let's talk about that. Next page. First, I have to show you how we write directions. Remember that 36.9 degrees north of east with Patrick the puppy? How the heck do we do that? So I've given you a whole bunch of vector directions. The dotted line is a reference. The solid line is the actual vector. And I'm going to show you how we write these. The first thing all of you are going to do on the page is you're going to go north, east, south, west. Put a little compass rose somewhere. Trust me. And I'm going to zoom in just a little bit. So, how would I tell you what direction this is? Well, 28 degrees. Can you look? This is the direction that we want to go. Here is the rule. Do you notice that there is one slanty line, Davis, and one nice line? And do you see what I mean by slanty and nice? What direction is the nice line pointing? Is that somebody at the door? Okay. Sorry? Can you all write of east? Leave a space in front of the of. And then Davis, if I start out going east, what direction am I going to hit this slanty line? North or south? That is 28 degrees north of east. I'll move it a little closer. The next one over to the right. This is 51 degrees. What's the nice line direction? Percy, what's the nice line direction? So it's not going to be dotted or solid in your diagrams because you're going to be drawing these. What's the non-slanty nice line? Of north. That goes last. What direction from north do I need to go to hit the slanty line with my eyes? This would be 51 degrees east of north. This is tricky, by the way. One of the smartest students I've ever taught in my 24 years, a young man named Dylan Gattner. Heck of a basketball player, straight A student, won the Governor General's Award, I think. He could not get this. He tried and he tried. He memorized all 16 different combinations. That was his way of learning it. You can do that, but Kyle, I'm going to say, Kyle, try and figure this out. It's better. Kyle, looking at this one right here, what direction is the non-slanty nice line? It's going to be 20 degree space of north. Which way of north to get to the slanty line? That's west of north. Okay. Elias, this next one, what direction is the non-slanty nice line pointing? So it's going to be 48 degree space of west. What of west? North of west or south of west? Getting the hang of it? This is how we define directions clearly in physics, in English. It's a little weird because the nice one is of second and it's easy to get mixed up. Owen, what would this one be? 78 degrees? Is he right? What would this one be? Jordana, 52 degrees? And I will give you directions like that in questions as well and expect that you can draw the slanty line in the right place. And I typically, of east, I would draw the east line as a dotted line first, go back to the beginning and say, south of east, drop down and draw the slanty line that way. Surprise, each one of these can be written in two different ways. Go back to the first one. Draw a little vertical dotted line like that. How big is this angle here? Sure. 62, because these two add to 90. The fancy word for that is they're complementary. My mom says I'm supposed to be complementary. She means something different. So this is 72 degrees. You could also have said 72 degrees north of south, east of west, what or what? 62. What did I did the same thing. Forgot to carry the 1. 62 degrees north of south, east of west, what of what? What's the nice line? North this time, so it's going to be of north. Which way from north do you need to go to hit the slanty line? Which way do I need to go to hit the slanty line? East of north. There's a pattern. There's a pattern. Hey, not only is this 51 degrees east of north, you could also get there by going 39 degrees north of south, east of west, what of what? So what you're going to notice for the first few lessons, in my answer keys, I will always put both of these because it all depends on the order that you chose to draw your vectors. If you added vector A plus vector B and you added vector B plus vector A, you'll get the same magnitude, but you'll each get the complementary angle. It's the same thing, but I'll put both answers. Eventually, I'll stop putting both answers, and I'll just assume, Matt, you can figure it out that, oh, Mr. Dewitt got 32 degrees east of south. I got 90 minus 32, 58 degrees south of east, same thing. So let's try the next one. How could I write 20 degrees west of north? In other words, this one right here, what would the magnitude be? 70 degrees north of west. The problem, Davis, is this, as much as anything, it's really easy to make a dumb mistake. And I guarantee I will make several of them as I'm teaching, and thank you for calling me, not just on the subtracting from 90 and forgetting to carry the 1, but I'll get east and west mixed up all the time. I draw the compass roses all the time. In fact, the fact that I've scrolled down and I can't see a compass rose is actually giving me angst right now. You all see yours on the page, but I would, if I was doing this on a test on something this big, I would write another compass rose right here as well, just because God, I'm going to get them mixed up. It's easy to do. 48 degrees south of west, or 42 degrees north of south, east of west, what of what? Hey, that's west of south. Start out going south, and then go west of south. What's the second angle for this one? 78 degrees west of south can also be written as 12 degrees. And that would be if you happen to use trig and you found that angle. And I'd give you full credit. I'll take both. We'd all get the same magnitude, because when you did the Pythagoras, you'd get the same magnitude, but you just drew your triangle different from me. 52 degrees south of east is 38 degrees. South of north, east of west, what of what? East of south. So again, I'll give you both answers for a while in my answer keys or on a quiz, but eventually I'll just expect you to clue in, I take both. So that's how we write directions. Now let's learn how to add vectors. You kind of know how to do this already. I snuck a little bit of this in last year. When I was saying winner minus loser, what I was really saying is let one way be positive, let one way be negative, and as long as they're in a nice straight line. So, well, how would you add 5 meters east? Oh, I see a compass rose. How would you add 5 meters east to 3 meters east? Don't overcomplicate it. This would be 8 meters. I usually put an at symbol and then east, and the reason is, what's the abbrev for north? What's the abbrev for newtons? And so if the N for newtons is in front of the at, in other words, if it was 8mn, that's millinewtons. That's meters north. I've probably mentioned once or twice that we don't have enough English language letters. I hope I said that once or twice last year. We don't. Ooh, 6 newtons left to 6.7 newtons right. And last year, Emma, we would have said, who's winning? The 6.7. Who's losing? The 6.2. I would have said, oh, when I said who's losing, you looked at, I would have done some joke like that, right? And anyways, what's the magnitude? What's the net force of those two? 0.5? Direction? What's the direction? Right? Right? Right, right? Right. If you wrote the word east, I'd give you full credit for that too. But just letting you know, last year I kept it mostly as forward and backward, up and down, left and right. Now we're going to get a little more meticulous. That third vector, that answer, represents the sum of the first two vectors. The fancy schmancy term for that, we call that the resultant. And I'll start to use that term. When you add two vectors together, the answer is the resultant. How do we add vectors in 2 dimensions? Well, we represent vectors with arrows. One way of adding vectors in 2 dimensions, Sky, would be to get out some graph paper to carefully draw everything to scale using a ruler and a protractor and graph paper, and then carefully measure the distance between. Or better yet, use trig. So the question is this: John travels 5 kilometers west, then 8 kilometers north. What's his resulting displacement? We're going to do that on the next page. But here in bold font, and if you want to, you can add this to your purple sheet. But I'm going to encourage you, don't yet. It's better that you commit it to memory. How do we add 2 vectors together? We draw them tip to tail. How do we add 2 vectors together? We draw them tip to tail. Percy, I want to add 2 vectors together. Any suggestions on how I might want to draw them? Kai, I got a hankering to add a couple of vectors together. Any suggestions on how I might want to draw them? That's a good suggestion. That's pretty good. Marcella, if you and I wanted to add 2 vectors together, any thoughts on how we might want to go about drawing them? Tip to tail. Armand, how do I add 2 vectors together? Draw them. Okay, you need to commit this to memory almost as much as, it's got to become almost as unconscious as breathing. We draw them tip to tail, and then the resultant is from the tail of the first to the tip of the second. You know what? I think I forgot to download this app, so I got to freeze the screen here, Mr. Dewick. This is what happens. So, here's a vector, vector A, okay? I'll make it a nice right-angled vector. I'll make it a nice line. Let's suppose we start out going east, and then we also go north, let's say that far. How would I add these together? See the tip of vector A? I would put the tail of vector B right there, and the resultant is from the tail of vector A to the tip of vector B. There's the resultant. See it? How could you find the magnitude of the resultant if you knew the 2 light blue lines? Pythagoras. How could you find the direction? Shift sine or shift cos or shift tan. And then north of south, east of west, what of what? So how do we add 2 vectors together? We draw them tip to tail. Okay? So let's do this. Example 4 on the next page. You're all turning the page, and we're about to do a vector question. So all of you are going to put a little compass rose somewhere next to example 4. And the 2 vectors that we're going to add together are 5 kilometers at west and 8 kilometers at north. Who remembers what DALP stands for? Draw a little picture. We're going to be doing that a lot now. So typically what I do is I'll write out, and eventually you'll get good enough, Davis, you can start taking shortcuts, but even on a test, I would not take shortcuts. So I would write those out, and then I would draw them. 5 kilometers which way? So I would draw an arrow pointing to the west, and I would eyeball it. I would say, okay, that's 5. I already checked my units all match, so I can add these vectors. I'm not adding kilometers and meters or kilometers and newtons or anything like that. What's right there, Davis, in between them? Be obvious. I would drop the plus sign down. And then I would draw 8 north, and I would try and draw it roughly to scale. What do I mean by roughly to scale? 8's bigger than 5, but not twice as big as 5. About like that? Davis, how would I add those two vectors together? Draw them. So what's it going to look like? Here's my answer. This is weird. I know we're doing math with pictures. This is vector mathematics. I would go 5 this way, and then tip to tail, 8 that way, and the resultant is from the tail of the first to the tip of the second. That is the displacement. I'll label that with a D and then a vector sign for displacement. How can I figure out the magnitude of the displacement? How can I figure out how big D is? Sorry? So D's the hypotenuse this time, so it's going to be D squared equals 8 squared plus 5 squared. So quickly on your calculator, can you find the magnitude, please? And let's go to 3 sig figs. In your homework, if you feel comfortable doing Pythagoras without writing down this line, I'm good with that. On a test, I would still write out that line, even though I can do Pythagoras in my sleep, because why take a chance of making a silly mistake? 5 squared plus 8 squared. I can't do this one in my head. Well, maybe. 64 and 25. So, is it 9 point something? Give it to me to 3 sig figs. 9 point what? Any 9.43? Is that what you said? Sorry, I'm having, keep the masks on, just talk a little louder. 9.43 units. Kilometers. And then now we need a direction at. Where is the theta going to go? Well, it's definitely not going in the bottom left because that's 90 degrees. So is it going to go in the top left or bottom right? Theta, and this is also you'll need to memorize, always goes from where the vector is originating. Theta is going to go right here. Did you figure it out, Jack, or not? Calculator issue? Okay, let me pause. Because right now, you're not catching the key stuff. Mentioned that 8. Oh, sorry. Color. That 8, opposite, adjacent, or hypotenuse. Good. That 5. Where the theta is. That's what I'm doing. And that's why I color it. It reminds me that's the angle I'm defining opposite and adjacent in terms of. And again, it's grade 12. How often do you get to color? Which trig function? Oh, did you all turn the page? Of course, when you turned the page, all of you did that at the top, right? Which trig function? Now, if you're good enough at trig that you don't need to write out SOHCAHTOA, I don't anymore. Fine. Which trig function? Tan. So in terms of showing work, I would look for this. Tan theta equals opposite 8 over adjacent 5. You don't need to show me any more work than that because the rest is on your calculator. How big is angle theta?
Don't forget to hit the shift button.
Now, you are going to notice you have to put it in brackets. So you'll have to go shift tan bracket 8 divided by 5, close bracket, to let your calculator know you're taking the inverse tangent of that whole thing. You get, 58 degrees? North of south, east of west, what of what? North of south, east of west, what of what? What's the nice, look where the theta is. What's the nice line right next to that theta? What direction is that? Of west. Which way of west do I need to go to hit my resultant? I don't know what that means. North. Okay? Now, I went 5 west plus 8 north. In your head, what's 6 plus 5? Everybody. What's 5 plus 6? When you're adding things, does the order matter or do you get the same answer? Same for vectors. When you're adding, order doesn't matter, but we went 5 west plus 8 north. It's possible that Elias might have gone 8 north plus 5 west. You would have gone like this and like that. Your triangle would look a bit different, but the resultant, I think that looks the same as what you ended up drawing. When you did Pythagoras, you would get the same value here of 9.43, but when you found angle theta, you would have found 32 degrees west of north, and that's why I take both answers. Usually I'll draw them in the order that they gave them to me in the question, just because I think that's what most of you will do and all our answers will look the same, but not always. Sometimes it's way easier to draw one version than the other. Example 5, I like example 5, I like example 5. Example 5 is a nice question. Force 1 is 10 newtons due east. I've scrolled down. I'm going to draw another compass rose. You probably still have one on your page. Force 2 is 6 newtons due south. Find the resultant, FR for resultant. Hint, Dulp. Okay. Since they actually gave me the forces right there, I'm not going to rewrite them, but I am going to say, okay, there's going to be a plus sign between them. Grace, what's the first vector? Magnitude and direction. So I'll eyeball it. Yoink, there's east. That's 10. What's the second vector? Magnitude and direction. Am I going to draw the 6 bigger, smaller, or the same size as the 10? Be obvious. And half as small? A little more than half as big. So I'll eyeball it. Ish. Sky, you could have drawn, if you wanted to, 6 first plus 10 next. You'll get the same answer as me, but you'll get a different theta and a different what of what. Oh, Grace, how would I add these two vectors together? Draw them. Thank you for not freezing. Good. Now, how many of you want to get these wrong? Anybody? There's always some kid who wants to get these wrong. They don't know it. But here's how I know they want to get these wrong. They go like this. If you draw a small triangle, you're setting yourself up for yuckiness. You'll notice I'm often giving you a full quarter page or a half page. I'm going to draw this big. So it's going to look like this. Yoink, 10. Yoink, 6. The resultant is from the tail of the first to the tip of the second, which kind of makes sense. You're going right and down, so your vector should point right and down. Where is the theta going to go? Where my vector is originating from. So is that going to be top left or bottom right? Top left. Theta goes there. Color, 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 color. Okay. So I'll label this slanty line with F for force and R for resultant, because that's what the question said to do. How can I find the magnitude? How can I find the magnitude? Looking for a word that starts with the letter P and rhymes with Pythagoras. Okay? So I wonder if I can do that all on my calculator. By the way, can you all look up for a second? I didn't put a vector sign on this D, and it's definitely a vector, and that's driving me crazy, so I should have done that. It's a displacement. What's the magnitude? 10 squared plus 6 squared, 136 square root. Square root of 121 is 11, so it's going to be 11 point something. 11.2? That's a guess. 11 point what? 11.7. Wow. Oh, yeah, it's close to 144. Sure. Oh. Units. Units. And that n is newtons, not north. At, if there's an n on the other side, that'll be north. That's 6, opposite, adjacent, or hypotenuse. What about that 10? And you'll notice I'm not bothering to use this, just in case we got the 11.7 wrong. I'm not going to use it to find the angle unless I have to, because why get a wrong answer accidentally? Which trig function? Tan? Oh, cool. Opposite, 6, over adjacent, 10. How big is angle theta? And again, I hope you're all trying this on your calculator and not just kind of following along mindlessly. Sam, what'd you get? North of south, east of west, what of what? Start out going east, south of east. I agree. Or 59 degrees east of south if you drew the 6 first and then the 10. And I'd give you full credit for that too. But you still get the 11.7. Emily, how do I add two vectors together? Draw them. How do I add two vectors together, Sky? Draw them. How do I add two vectors together, Alex? Draw them. What? Sky, how do I add two vectors together? Draw them. Emily, how do I add two vectors together? Draw them. Tip to tail. Everybody, how do I add two vectors together? Draw them. Tip to tail. How do I add two vectors together? Draw them. Tip to tail. And then the resultant goes from the tail of the first to the tip of the second. Let's do a physics problem. I like example 6. I like example 6. Example 6 is a nice question. Oh, it's been a year. Why would I say that? Did you hear me say it's going to be on the test? You're the student that notices when a teacher tends to emphasize things? Good, 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 good. A plane is flying due north at 132 meters per second. A crosswind is... I got to draw compass rose. A crosswind is blowing due east at 44 meters per second. What's the plane's resultant velocity relative to the ground? This is one of my big pet peeves. In the industry, they'll call it the plane's ground speed. They should be calling it the plane's ground velocity, but I will call it ground speed because a few of you have told me that you do want to get into aviation, and so I will use the industry term. It's a vector. Shouldn't be ground speed. Should be ground velocity. Hey, if you look on your purple sheet, I think you have an equation that relates plane speed, airspeed, and ground speed. It's the first one. Okay? Or I think it's near the top anyways. Might be the first one, near the top. So here's what we're arguing. When a plane is moving through the air, it's being pushed with its engines and plus it's being pushed by the wind, and the combination of those gives you your resultant ground speed. That's a G. There's our starting point. Okay. What is the engine speed, magnitude, and direction, Matt? Not Matt, but Matt. You had to sit right by each other, didn't you? That's not going to be awkward. Matt B, what's the plane's engine speed, magnitude, and direction? I'll give you a hint. It's the first one. Thank you. So I'm going to draw a line underneath V engine line, and I'll call that 132. Plus east to the right, 44, about a third as big as the 132, eyeballing it. So, Matt, how might I add those two vectors together? Draw them. So, 132, 44, and this, before we had fancy schmancy GPS and software, if you were, for example, a passenger jet pilot, you would be calculating this by hand. Although what you would actually do is you would try and figure out how far off will the wind push me and what do I need to do to compensate. In other words, you were interested in finding which way you had to point your plane. How would I get the VE by itself? How would I move the V wind over? Well, what's the V wind doing to the VE? How do you subtract vectors? That's preview of coming attractions. Okay. Anyways, the resultant here is going to be yoink. Here is the ground velocity. This angle is 90 degrees. Where is theta going to go? Bottom left or top right? Where the vector is coming from. Color, 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 color. Okay. What's the magnitude? What's the ground speed, but no direction yet? How would I figure that out? So I hope you're all typing on your calculator now. Right, Elias? Right. What is, I guess, 132 squared plus 44 squared equals square root? Or you can do it in one step. I have no idea what the answer is here. Well, I can tell you it's going to be bigger than... How can I tell that it's going to be bigger than 132? What side is it? Really? Really? Huh. So, if the ground velocity is always the hypotenuse of the triangle, is the magnitude going to be more, less, or the same as in still air? Always, because it's going to be the hypotenuse. Okay? But I hope now you're going, oh yeah, I hope that now makes sense. Okay? No matter which way, so what if the plane is flying this way and the wind is blowing that way? It's still a hypotenuse. As long as it's a crosswind at 90 degrees, its speed over the ground will always be larger. It has to be. It's the hypotenuse. Has to be. Okay? Now, if it's not at a nice right angle, that's a different matter. But as long as it's a straight crosswind, you'll always have a larger speed over the ground. Sorry, what was the magnitude? 100 and something something? 139? So you'll notice that crosswind isn't making that big a difference to its overall ground speed magnitude. In still air, 132. In the crosswind, 139? Units, meters per second, at that 44, opposite, adjacent, or hypotenuse. What about that 132? Mr. Duick, I notice it's tangent again. I notice it was tangent here and tangent here. Will it always be tangent? No, but usually. When won't it be tangent? When I give you some weird ones, preview of coming attraction. So don't memorize, oh, it's always tangent, because it won't be. But it'll usually, if it's a simple question, be tangent. Tan theta equals opposite over hypotenuse. How big is angle theta? I'm a little worried because I see a lot of people not on their calculators. I'm hoping it's because you've done it already. But if you're not following along or you don't know how to get this, you need to let me know this afternoon and I'll walk you through it in a blended session, okay? It's going to be shift tan of 44 divided by 132. 18.4 degrees. North of south, east of west, what of what? East of north. Or, Matt, if you drew the 44 first and then added the 132, 90 minus this, you might have said 71.6 degrees north of east, and I'd give you full credit, but you'd still get the 139. Three forces are acting on the same object. Force 1 is 5.5 newtons south. You know what? I've scrolled down. I'm going to put a compass rose. Force 2 is 8.6 newtons west. Force 3 is 10.6 newtons south. What's the net force, or what's the resultant? Dulp. I guess we're going to add force 1 plus force 2 plus force 3. How do we add two vectors together? Draw them. People, please. How do we add two vectors together? Draw them. How do we add three vectors? Let's see if we can figure it out. Let's dulp. 5.5 newtons south. So under F1 plus 8.6 newtons west. A little bigger than the 5.5. Plus 10.6 newtons south. I don't know if you've ever noticed, but if I ask you to go 6 plus 2 plus 4, there is no way to add three numbers at once. You add two numbers, 8, and then add the 4. There is no mathematical algorithm to add three numbers at once. We're going to do the same thing for three vectors. You add two of them together, get a resultant, and then add the third. Although, if you were adding these three numbers, if you were clever, which two would you probably add together first in your head? Why the 6 and the 4? 10 and then plus 2 is? Okay. If you were clever, which two vectors would you probably add together here? Why the south and the south? I can do that in my head without having to do a big redrawing. What is 5.5 south plus 10.6 south? Okay? See, it's this exactly, Jack, what you learned intuitively with numbers. The same stuff will work with vectors. We just have to be more careful. So I'm going to argue that this here is the same as how many south? 16.1 plus, and 8.6 is roughly half of 16. That's what I'm going to add together. So how do I add three vectors together? I don't. I add two, get an answer, and then add the third tip to tail. But if you're lucky, two of them will either be in the same direction or in opposite directions, and you can just go winner minus loser and put it into one pretty easily. Marcella, how will I draw these? How will I add these together? Draw them. So 16.1 down. 8.6 sideways. Try this one on your own. I'll do it up here. I won't freeze my screen, but I won't give you any narrative. Try getting the magnitude of this resultant on your own. Yeah. Oh, the 8.6, I pointed the wrong way, Mr. Dewick. Jordana, candy for you. Boy, did I watch. How am I going to draw that? I guess I'm going to have to start with the 16.1 over here somewhere so that I have enough room to go this way. I kind of have to imagine the triangle a little ahead of time. If I had accidentally done this, and then that, now I'm starting to run into my old equation. So kind of imagine, plan it out. Imagine where you're going to go. I mean, I can fit it in, I guess, if I go like this. There's 16.1. Thank you, Jordana. 8.6. I wish I'd done that on purpose for good teaching, but I didn't. Find the resultant of that magnitude and direction, please. So this is the resultant force. Magnitude, oh, did I hit record? Yeah, I did. Magnitude is going to be 16.1 squared plus 8.6. Color. North of south, east of west, what of what? I got 18.3 newtons at 28.1 degrees west of south. Or if you drew the 8.6 first and then the 16.1, you would get 61.9 degrees south of west. Same answer. That all right? How many got that? Okay. Okay. So how do we add vectors together? We draw them tip to tail. How do we add 3 vectors? Turn it into 2 vectors. How do you subtract 2 vectors? You don't. Huh? How would I turn it into an addition? How the heck can I turn 5 take away 4 into an addition question and get the same answer? What? We'll add the opposite. There is a rule for subtracting vectors. It's complicated. You draw them tail to tail, and then the resultant goes from the tip of the longest vector to the tip of the... And I used to do it that way. It's how I was taught in university. And then I said, why would I memorize a completely new rule when I can turn it into something I already know? In the same way, there is a rule for adding 3 vectors together, and you can actually do it in this app. If I bring out a third vector, let's get rid of the vector sum. If I want to add a third vector, you draw them all tip to tail, tip to tail, tip to tail, and the resultant is from the tail of the first to the it's doable, but how do you solve a trapezoid or whatever shape that is? Your trig starts to break down. You can have quadrilateral geometry. There is a branch of math that can handle that, or better yet, add 2 of them together, get an answer, and then add the third one, and you're back in triangle trig land. I'd do it that way. Okay? I might have showed you this last year. This is from the Foxtrot comic. Jason and his older brother Peter are playing football. Jason, what pattern did I tell you to run? You said go 10 yards out and then 10 yards to the right. What pattern did you run? I went 10 root 2 yards at a 45-degree angle. Are they the same thing? Well, if you had the vectors, sure, they are. This is football, not math class. Why do you think I rounded to 2 decimal places? And then I think this one I showed you last year. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 25 yards, then turn right again and go 30 yards, then turn right and go 30 yards, then turn left and go 10 yards, then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. If you add all of those vectors together, tip to tail, 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 you end up right back where you started from. It's a vector 0. By the way, if you're ever adding 3 vectors together, and you end up right back where you started from, that would be a net force of 0 or a displacement of 0. So if you end up with a closed triangle because you were adding 3 vectors together, that's also a strange looking 0, but that's a 0. What's your homework? I have your first take-home quiz. What? We may mark it later in class. I'll give it to you in just a second. Take a look at the take-home quiz. Quiz 0. So all I'm asking you to do is draw these. So we have vector A, which looks like it's going right or east. Vector B, vector C, vector D. What do you think A plus B would look like? Add them tip to tail. What do you think B plus A would look like? C plus B. Ooh. Haven't quite done one like that. What would make sense? B plus C. A plus C. A plus B plus C. 2a. How do you multiply vectors by a scalar? I'll let you think about that. What would make sense? A plus D, B plus D, 2b, or not 2c, and then what would 2a plus D look like? I would love it. It's 10:10. I would love it if maybe I could mark it at about 10:45 in class, and that way you can. So try the quiz first and then work on your trig homework, okay?